The impact just 6 months away, there's not enough time to launch a spacecraft to make up-close observations. So virtually nothing will be known about the asteroid's size and the damage it might cause.
The risk corridor. Let me move ahead through a lot of this stuff to...
By the end of the first week, the probability of the asteroid hitting the Earth has climbed to 5%, or 1 chance in 20. As to where the impact may occur, the potential areas are at first literally all over the map, covering 2/3 of the Earth's surface.
Large swaths of the Earth are at risk initially, and it's our job to get a better and better orbit to narrow that down so that we know where the asteroid is headed and we can isolate the region of the Earth where it might hit.
To make matters worse, for the next few days, new observations by ground telescopes aren't possible due to the glare of a full moon. Astronomers use this time to search through their archives, looking for any possible past signs of the asteroid buried in their records. Meanwhile, for policymakers, a major question is what information should be shared with the public and when.
The data on which we base our orbit calculations are really international in scope, and they're available to all around the world. And the other orbit computers can run their calculations, maybe not quite as elaborate as ours, but come up with similar results. So it would be very difficult to kind of sit on this impact prediction and not tell anyone.
The group's suggested headline doesn't mince words. Newly discovered asteroid poses risk of Earth impact in 6 months.
These are just nominals.
Another week goes by. The effort to comb through past data has paid off. It shows that the asteroid had passed by unnoticed 7 years before. With this orbit data in hand, a better prediction of the asteroid's flight path can be constructed. The news is not good. The impact probability is now 100%. The potential target areas are narrowing too. A new headline is prepared. New observations confirm asteroid will impact in 6 months. The regions at risk are Europe and North Africa.
In this particular scenario, with only a few months of warning, it's really impractical to think that we could deflect this particular object. So then this scenario was designed more or less to deal with the civil defense issues of what you would do to evacuate areas once you knew more or less where it's hitting and once you knew more or less its size.
If the asteroid is as large as 160 feet, the impact is expected to be as powerful as the atomic bombs used in World War II. If it is 1,000 feet in diameter, destruction would be measured on a continental scale. A half-mile wide asteroid could mean global catastrophe. Meanwhile, an international effort has been exploring how a space mission might protect the Earth.
We did talk about what we could do to mitigate and whether there would be any possibility, but with 6 months, there's not much.
It's soon apparent there's not enough time to attempt a deflection technique that might knock the asteroid off course. The only option left is to try to launch a spacecraft armed with a nuclear explosive device.
You have engine ignition?
And because so little is known about the asteroid, the recommendation is to send as large a bomb as possible, and then hope for the best. Of course, this assumes that a spacecraft capable of being quickly armed with a nuclear device is possible. Currently, no such rapid response capability is known to exist. Meanwhile, observations by the infrared space telescope NEOWISE provide the first information about the asteroid's size. It is likely no more than 500 feet in diameter, and the impact zone has narrowed down to a region mostly within Germany, Czechia, and Austria. Among the cities at risk are Munich, Prague, and Vienna. It is now 6 days until impact. The asteroid is 4 million miles away and now in range of JPL's radar imaging assets. The size of the asteroid is further refined. It is somewhere between 300 and 400 feet in diameter. Estimates of how powerful the impact could be range from 9 to over 150 megatons. To give those numbers meaning, a single megaton contains the energy equivalent of 1 million tons of TNT. The day of impact arrives. The asteroid enters the atmosphere at the precise time predicted. The world can only await what will follow. Today, we know of more than 1 million asteroids in our solar system, and thousands are found every year. Most reside in the asteroid belt between Mars and Jupiter, and they pose no threat from that location. Of concern are asteroids that are nearer, especially those that can cross Earth's orbit. It's believed that 90% of the near-Earth objects that could cause a global catastrophe have been found. But there are estimated to be thousands of asteroids large enough to cause severe damage over a wide region that have yet to be discovered. But that knowledge doesn't seem to keep asteroid hunters awake at night.
These events are so very unlikely to happen that it's not something that we lose sleep over. In fact, I feel more confident in the sense that we have capability to deal with them.
Out of the tabletop exercise, there was one big takeaway: greater awareness of the extreme challenges that come with a late discovery.
The bottom line of that exercise is that that asteroid could have been found earlier, at least 7 years earlier, with a better asteroid survey, a more sensitive survey, such as NEO Surveyor.
Had a more robust detection system been in place that included a space infrared telescope, this fictional asteroid might have been known years earlier, allowing for a number of mitigation options. There could have been time to build and launch a reconnaissance spacecraft to determine the asteroid's composition, mass, and size. With that knowledge, a plan of action to divert the asteroid could have been devised. So what is the best line of defense? The answer is worth repeating.
The primary goal for defending against near-Earth objects that are on Earth-impacting trajectory is to find them early, and find them early before they find us.